Hello class, sorry I wasn't there today. Hopefully this video will help make sense of what we're doing today. Today we're going to talk about perpendicular bisectors of chords. We know all of these words separately, right? Perpendicular means that two lines meet at 90-degree angles. We talked about how tangent lines are always perpendicular to the radius last class. And we know what bisector means because we've talked about that in a lot of our proofs. A bisector cuts something into two equal parts. It can cut an angle or a line. Okay. Now, when we have a perpendicular bisector of a chord, it's when a chord gets cut exactly in half and it creates 90-degree angles. Okay. If we have a chord, so say we had this original chord, and it made 90-degree angle with another line, then these two sides where like how it gets cut in half have to be equal to each other. That's what a perpendicular bisector says. It says if you know that a diameter or a radius is perpendicular to a chord, so if you know that there's a 90-degree angle between the diameter and the chord, then that means that these have to be equal to each other. Now that's true for diameters or radius, or radii, I guess, okay? So if you see that 90-degree angle, then you know these two are equal to each other, okay? We're gonna do our notes a little backwards today. We're actually gonna skip these examples for now, and we're gonna jump down to the check your understanding. We're gonna do these first, okay? So I have a circle R, it's got a diameter of 40 centimeters, and this chord ZV is 28 centimeters, okay? And it wants us to find all the following information here. Okay, it wants us to find RT. R to T, wants us this, okay? Well, this starts at the center, goes to the end of the circle, or you could say starts at the circle, goes to the center. Okay, that is a radius. We know that the radius is half of the diameter, right? Because the diameter would start here, go to the center, and then go to the other end. So if we're trying to find what this radius is, all we got to do is take our full diameter, which is 40, divided by 2. That tells us that this is 20 centimeters. Okay? Now WV, so we want to find the distance from here to here. Okay? Well, we do have, just like this was a radius, this is another radius here. RU is another radius, right? From the center to a point on the circle. We also know that this chord meets the radius at a 90-degree angle, as shown, okay? Now in our quick notes, we said if a chord meets the radius at 90 degrees, then that is a perpendicular bisector, which means these two sides have to be equal to each other, okay? These have to be equal. Since I know that the whole distance of ZV is 28 centimeters, then that means half of that distance is 14 centimeters, and this is also 14 centimeters. So WV is just 14 centimeters, okay? Now it wants us to find the distance of RW. So it wants this distance right here, okay? I don't know what this distance is, and I can't, I don't know, for example, that this is exactly cut in half, so I can't just use that fact. This is the only line that gets cut in half. What might help me, though, is because I know the distance of the radius, I can draw a new radius that's not necessarily already drawn for me, right? A radius can be from any point to the center, right? That could be a radius. So I could find one that helps me and use that. So I'm going to draw one from Z to R. Because if I draw this radius, I know that this is 20 centimeters, okay? I also know that this is 14 centimeters. I know this is a right angle because all of 4 of these are right angles. And so I have a right triangle that's missing one side, and I know how to solve those. We've been doing this for a long time. It's the Pythagorean theorem. Okay, so if I called this A because it's one of my legs, right? Then I have A squared plus B squared equals C squared because my hypotenuse is always C. So I'm going to write that down. I've got A squared plus 14 squared is equal to 20 squared. Okay, and now we can just solve for A. So I've got A squared plus 14 squared is 196. And then 20 squared is 400. Okay. Then, to get AL by itself, I've got to subtract this 196 from both sides. It's going to leave me with A squared is equal to 204. And then the last step to get AL by itself is I got to get rid of this square. So I'm going to square root both sides. So A is going to equal 14.28 centimeters. Okay. So the distance between R and W is 14.28 centimeters. Okay. And then the last question, or on the last little thing on question 1, it wants to know the distance between U and W. So it wants to know the other part here. Okay. The easiest thing to do here is, well, we know that the distance between R and U is 20 centimeters because that is a radius of this circle. And we also know that the distance between R and W is 14.28. We just found that. So if I take my total distance, 20, and I subtract my little segment here, that's going to give me just this part here. So 20 subtract the 14.28 that we just found gives me that the distance between U and W is 5.72 centimeters. Okay. All right. Now question 2. So for X, okay, well, I've got this circle here. This is a diameter. I know that the diameter touches this chord at a 90-degree angle. I also know from the quick notes that if the diameter meets a chord at a 90-degree angle, aka it's perpendicular, that means that the two side lengths have to be congruent to each other, okay? Because of that 90 degree between the diameter and my chord, those have to be equal. So if I'm solving for X, I know that this distance is equal to the other distance here. Then I can just set these two values equal to each other. So 3x plus 7 is equal to 5x minus 5. Okay, and now I'm just going to solve for x. So my first problem, I've got an x on both sides. Got to get rid of one of them. So I'm going to subtract 3x from both sides. When I subtract 3x from both sides, I get 7 is equal to 2x minus 5. Okay, now I'm trying to get x all by itself. So first I'm going to get rid of this minus 5. I'm going to add 5 to both sides. That's going to give me 12 is equal to 2x. And now to get x all by itself, just get rid of this 2 that's timesing by x. So I'm going to divide both sides by 2. It's going to leave me with 6 is equal to x. Okay. And voila, we've solved for x. Okay. Now we're going to go back up here and we're going to solve these examples. This is what your homework is going to look like, okay? So your homework is going to be using all the information that we've learned so far in the unit. So it's going to be using your vocabulary. It's going to be making sure that you know the difference between a chord and a radius. And it might use what we learned last time, that tangent lines are always perpendicular to the radius. Might use what we learned today, that if we have a radius or diameter that meets a chord at 90 degrees, then the two sides of that chord are equal. It is a bisector of that, okay? It's also going to use the Pythagorean theorem, because if we have all these right triangles, we can find missing side lengths using the Pythagorean theorem. So let's check it out, okay? So we have circle E, the diameter is CD, so that's my diameter, and my radius is EA. AB, this side is tangent to E at A. That tells me that this is a 90-degree angle, right? That's what we learned last time. We also know that EA is 13. So this distance right here is 13. And we know that EB is 23. So E to B, this distance right here, is 23. Okay, I'm trying to solve for AB. So this right here. Okay. Well, I know this is a right angle because we learned that last time. I know this is 13. I know this is 23. And I'm missing one side of a right triangle. I'm going to use Pythagorean theorem here. This is a leg and this is a leg. That's my hypotenuse. So I'm going to call this A. That's what I'm solving for. And we're going to set it up Pythagorean theorem. So A squared plus 13 squared is equal to 23 squared. Because remember, our hypotenuse is always C. All right, so let's simplify. We've got A squared plus 169 is equal to 23 squared, which is 529. Then we got to solve for A, so I'm going to subtract 196 from both sides. That's going to leave me with A squared is equal to 360. And then I have to square root both sides to get A all by itself. That's going to be A is equal to, and it rounds to 19 when I round to the nearest tenth, like it says. Okay. Perfect. So that distance is 19. All right. Question 2. Given circle E with diameter CD and radius EA, AB is tangent to E at A. Okay, so that means that this is a 90 degree. So we have a tangent line. It says AD is 3. So this distance right here is 3. Okay, and ED is 4. So this distance right here is also 4. Okay, solve for AC. So I'm trying to find this distance right here. Okay. Here's what we have. Okay, if I'm kind of ignoring that first 90 degree angle that I put there, okay, I can kind of see the outline of a triangle, right? If I connected these, then I could see a triangle here with a 90 degree angle, okay? Now the question is, because I need this full side length if I'm going to solve for this missing side length, what is this full side length? Well, E to D goes from the center to a point on my circle. So that is a radius. So I know that the radius is 4. Well, E to C is also a radius, right? So this is another 4. And if I add those together, I get 8. That's the total side length. That is my diameter, right? It also says here, that's the diameter. So now I have this side length and this side length. I'm just missing this side length, which I can solve for using the Pythagorean theorem. I'm going to call that A because it's a leg. That's a leg, and this is my hypotenuse. So A squared plus 3 squared is equal to 8 squared, right? Because we're adding those together. Okay, A squared plus 9 is equal to 64. And A squared is equal to 55 because I have to subtract that 9 from both sides. And then last step, to get a all by itself, I've got to square root both sides. So a is equal to 7.4 when we round to the nearest tenth. Okay. Perfect. Okay, example 3. Given circle E, got a diameter of CD, radius EA. AB is tangent to EA. And we know EA is 18. Okay, so that means our radius is 18. Good to know. We know that AB is 24. So this distance is 24. And we're trying to solve for EB. So this distance here. Okay, well, I see a triangle here. This is a 90 degree because remember, tangent lines are perpendicular to the radius, meaning that this is a 90 degree angle right here. And I've got one leg, two leg. I'm solving for my hypotenuse, so I'm going to call that C. And we're going to plug that into the Pythagorean theorem. We've got 24 squared plus 18 squared is equal to C squared. I'm solving for. 24 squared is 576. 18 squared is 324. And we still have that equal to C squared. Well, 576 plus 324 is 900. So 900 is equal to C squared. And if I take the square root of both sides, I get 30 is equal to C. So that hypotenuse, or the distance between E to B, is 30. Okay, and question 4. Circle E has a diameter of CD, a radius EA, and AB is tangent. Okay, EA is 15. So this right here is 15. My radius is 15. DB is 8. So the distance between here and here is 8. Okay, I am solving for AB. So I'm looking for this distance here. All right. Here's what I'm thinking. We could do the triangle one of two ways, right? We could find the distance of this chord and then have this be our triangle. Problem with that is I don't necessarily think that this is a 90 degree angle, so that's probably not the option we want, and we don't know what the distance of that chord is. What we do know is that this is a radius. We already know one of our radius, it's 15, and they have to be the same, right? So if we said that this was also 15, right? So let me put that down. I know that this distance right here is 15. So if I add those together, I get my full side length here. I already have this side length, and I'm just needing to solve this. And I also know that because this is a tangent line and my radius, that is a 90 degree angle. So I think that's the way we should solve this one. Okay. So we know the hypotenuse, know one of the sides. We're solving for another side, so I'll call this A. We've got A squared plus 15 squared, because that's my other leg here. And then is equal to 15 plus 8, which is 23 squared. Okay, so A squared plus 15 squared is 225. Is equal to 23 squared. Well, 23 squared is 529. Then to get A all by itself, we've got to subtract 225 from both sides. So I'm going to have A squared is equal to 304. And then my last step to get A by itself is square root both sides. So I'm going to have A is equal to 17.4 when I round to the nearest tenth. Okay. All right, we've got two more examples here, 5 and 6. Now, because I did the check your understanding, I'm going to switch it, and these two questions are going to be your check your understanding today. Okay, so get these two done. When you get done with these, you can grab your homework and get started on that.